Hello gentlemen, welcome back. We're going to continue here in chapter 3. We're going to start looking at logarithmic functions. Um, and hopefully you understand exponentials because they are related actually, as you're going to see. Well, let's get started. I want to define a logarithmic function. Okay, so we have x is greater than 0 and a is greater than 0, and again a cannot be equal to 1. We're going to say that y is equal to log, this is base a of x, if and only if x is equal to a to the y. Okay, the function log base a of x is called the logarithmic function with base a. And the thing that we have to note is that log base a of x and a to the x are inverses of each other. Remember in the last video we talked about how a to the x, this function right here, was 1 to 1. And remember back in chapter 1 we said that functions that are 1 to 1 have inverses. And so the inverse of the exponential function is a logarithmic function. Okay, so exponential function of base a, the inverse is a logarithmic function of base a. And let's see how we can relate those. Okay, that means that if I have the equation y is equal to log base a of x, then I can say that x is equal to a to the y. These are equivalent statements. Okay, they mean the same thing. That means that, again, but going back to properties of inverses, that if the log of base a of a to the x, well, that just has to equal x. Remember that what one does, the other undoes, and a to the log base a of x is equal to x. Okay, those two statements are properties of inverse functions. You need to remember those. Okay, and so the statement y is equal to log base a of x means that x is equal to a to the y. You need to understand this is called the logarithmic form right there. This is called the exponential form. We need to be able to use both of these, but understand that these two statements are equivalent. Okay, let's do a little bit of practice here. Okay, there's a logarithmic form, there's your exponential form. So let's go from one to the other. Okay, so if I have if I have y equals log base 7 of 49, that means that 7 to the y is equal to 49. Okay, this is the logarithmic form, this is the exponential form. Okay, they mean the exact same thing. I can rewrite 49 as 7 squared. Using the 1 to 1 property, we know that y must be equal to 2 here. Let's look, log base 2 of 32 means that 2 to the y is equal to 32. Let's write 32 as a function, as a power of 2. So we'll get 2 to the y equals 2 to the 5th. Again, using the 1 to 1 property, we get y is equal to 5. A little bit more difficult here. This means that 10 to the y is equal to 1 over 1,000, which is 1 over 10 cubed, which is 10 to the negative third. Remember our use of negative exponents here. And again, using the 1 to 1 property, we're going to see that y is equal to negative 3. Okay? Note that when we're doing this, when we take a log, we're looking at the exponent. Okay, well, that's what we're getting as a result. Log base 4 of 2 means that 4 to the y is equal to 2. Now we gotta rewrite 4. We're going to rewrite 4 as 2 squared. We can't do anything here. Let's rewrite 4 as 2 squared. Now we have a power to a power. We talked about that in the last video, which means that we multiply. So that's 2 to the 2y is equal to 2. The 1 to 1 property tells me that 2y is equal to 1. Remember the exponent there is 1. And if I solve for y, I get y equals 1/2. And so basically it says 4 to the 1/2. 4 to the 1/2. Remember 1/2 means that's the square root of 4. And we know that the square root of 4 is equal to 2. Okay? Let's look at some properties. Log base a of 1 is equal to 0. Okay? Which means, again, that a to the 0 is equal to 1. Okay, that's what, this is the logarithmic form, this is the exponential form. So a to the 0 is equal to 1. Remember, a is not equal to 1 or 0 here, and a is greater than 0. Log base a of a is equal to 1. Okay, that's the logarithmic form, but if we look at exponential, that means that a to the first is equal to a, which we know is true. Log base a of a to the x is equal to x, and a to log base a of x equals x. I did this on the first slide. I wrote that out, and that's because of inverse properties, right? Because these two functions are inverses of each other, we can have the composite function of each of them, and I just get back to x. What one does, the other undoes. Okay? If log base a of x is equal to log base a of y, then x equals y. This is the one-to-one property. Okay? Logarithmic functions with base 10 is denoted simply as log. There's no subscript. It's called a common logarithmic function. Okay, and you can see that on your calculator as well. Let's look at the graphs of logarithmic functions, and let's use the fact that exponential and logarithmic functions are inverses of each other. And remember that when we have inverse functions, the domain of one is the range of the other. So we know that the domain of the exponential function is all real numbers. Therefore, we know that the range of the log function, or logarithmic function, is going to be all real numbers. Now, we also know that the range here, we know what it is. It's 0 to infinity. And we know that the range of this function is going to be the domain of that function. Okay? Now, let's look at the y-intercept. The y-intercept for the exponential function was 0, 1, and that means that the x-intercept of the logarithmic function is going to be 1, 0. We know that there's a horizontal asymptote, which is the x-axis. That becomes, for the logarithmic function, the vertical asymptote is going to be y-axis. Okay, and both functions are going to be increasing, and both functions are going to be continuous. Okay, if you recall, inverse functions are mirror images across the line y is equal to x. So here's an example. This is y is equal to 2x. This is the the exponential graph on this side. If I flip that over, here's my logarithmic graph. Okay, this is the point right there. That's the point 0, 1, comma 1, and this is the point 1, comma 0. My horizontal asymptote for the exponential function, the x-axis, becomes the vertical asymptote for the logarithmic function. Okay, note that both of them are increasing. Okay, this is increasing much more slowly than this one is. Okay, understand how the domains and ranges switches. The domain for logarithmic function is all real numbers greater than 0, which is the range of the exponential function. Okay, make sure you guys understand these graphs. And again, where the base changes is just going to change how steep these graphs are, but the general shape will be the same. And again, we can also do vertical and horizontal shifts on these graphs like we did for exponential functions. Okay, here's some pages to read with some examples I want you guys to look at. I know this seems like there's a lot of problems here, but they're pretty straightforward. Make sure that you guys are practicing and emailing me with any questions. But to summarize, we looked at the logarithmic functions. We understood that logarithmic functions are the inverses of the exponential functions, and we looked at their graphs. Okay? If you guys have any questions, please make sure to email me, and have a nice day.